So we are going to determine the force in each member of the truss shown in the figure, and also we are going to state whether each member is in tension or compression. So as we have discussed in the class, so this is the free body diagram of that particular given problem. So you know that we are having two supports, that is one support at point A, okay, and another support is at point H. Okay, so this one is pin joint and this one is a roller support. So as we come across, the roller support will have a vertical reaction, so I am taking it HY. The horizontal reaction, this is HX, will be 0 because it is along the roller direction. So any horizontal forces, this particular support won't arrest. So HX will be 0. So we no need to consider this. Okay. But in pin joint, you are having two reactions. That is, one is vertical reaction and another one is, I am assuming this direction as AX. Okay. Pin joint AY and AX. And in H, you are having only one vertical reaction, that is HY. Because this particular truss is symmetrical about Y axis, and also even the forces also, if you see, it is acting same. It is 5.7 and 10.5 this side, and here also you can see 5.7 and 10.5, and here it is 9.6 kilonewton. So due to symmetry, so we can calculate easily the reaction forces. So how to calculate? Actually, the total load which is acting on the entire system, okay, divided by two reactions, that is AY and HY, is nothing but the value. That is, what I am trying to say is AY, that is vertical reaction at point A due to pin joint, and vertical reaction due to the roller support at point H, okay, that is equal to total load acting on the system divided by 2. So if you are calculating the total load of the entire system, that is total load is, if you see, 5.7 plus 10.5 plus 9.6 and again plus 10.5 plus 5.7, so total divided by 2 if you are given, so you will get 21 kilonewton. Okay. As based on that, we can write that AY, that is vertical reaction, and the reaction at point H along vertical is equal to 21 kilonewton. This is our first finding. Okay. So after that, we know the another one, that is summation of Fx is equal to 0, that is horizontal force. Okay, you know that. So I am taking that right side is positive. So there is no horizontal force. So obviously the Ax will be equal to 0. That is, reaction along horizontal direction at point A will be equal to 0. Okay, this is the first thing. So we have considered the entire system, and then we have calculated the values of vertical reaction at A, that is AY, and vertical reaction at H, that is HY, and then we have calculated the horizontal reaction at A, AX, and obviously in H there won't be any horizontal reaction, so obviously it is 0. So this kind of symmetric system, we no need to calculate the moment about the entire system, because the forces, due to the forces, what are the reactions, we have easily calculated. Okay. Next one, we are going to calculate the member forces of each system. Okay. So for that, as we have discussed in the class, we are going to see one by one. So you know that now the value of reactions, that is, you know the value here, that is AY, you know what is the value, that is 21 kilonewton. Okay, and AX, you know the value, that is 0, and then HY, you know the value, that is 21 kilonewton. Okay, fine then. So a little bit I will increase the thickness so that you can understand. 1 minute. Fine. So now we are going to calculate the member forces. As I said, member forces. So due to symmetry, so if suppose I am calculating the force acting on AB, for example, okay, that will be same as the force acting on FH. Okay, the one will be equal to AB. Are you getting? Similarly, all other members, that is, whatever force acting on BD will be equal to DF. Okay, and similarly, whatever the force acting on BC will be equal to FG. Okay, and whatever the force are acting on AC will be equal to HG. Okay, and whatever force are acting on this particular member, that is DG, will be equal to DC. Okay, so all these things, any one side, if you are calculating symmetry about any one side we are calculating, remaining things we can simply relate it. Okay, that's the thing. So now in this problem I am going to consider joint A, joint B, and then joint C, so that what I can calculate is I can calculate the forces on AB, and then I can calculate the forces on AC, and then I can calculate the forces on BD, and then I can calculate the forces on BC, and then I can calculate the forces on CD, CE. Are you getting? So all these related forces I can easily calculate. Okay. So now, as we discussed, we are going to see the first joint, that is joint A. So when I am considering the joint A, you know that what are the forces are going to act. That is, if I am considering the point A, so there will be the first force that is acting, that is 5.7 kilonewton at point A. Okay, this is the point A, and then there will be a force from A. This is point A. Okay. From A, there will be a force FAC, the member force, and then I will have another force that is along B, that is force FAB. Okay. Apart from this, I will have one more force that is nothing but the reaction force AY. Okay. So now what we can do, we can put it in the resolution of forces, and then we can calculate FAB. Then this is nothing but FAC, and then you know here it is 5.7, and here you know the value, that is 21. Okay, so now you can use the resolution of forces formula, and then we can calculate. Okay, so anyway I'll explain one by one. So once you have come across this, then you can write the equation summation of Fx is equal to 0. So in this condition, you know FAB, so we have to calculate this theta. So how to calculate this FAB theta? Okay, for that I think I can explain here, you will understand. So when you want this particular angle, okay, so you should calculate this entire length. Please don't stop within the length of 3.8 meter. Okay, this is wrong. So you have to consider the entire length. So the entire length here is 7 meter. Okay, and this vertical distance, you know, it is given 2.4. So this theta you can simply calculate as theta is equal to tan inverse of, you know, that 2.4 divided by 7. Okay, so you will get the value of theta 1. So you can substitute here. Okay, so once you are substituting, what will be your formula? The first one will be, so you know that you are having AC, so you can write the equation as FAB. It is in positive, I am taking right order as positive. FAB, okay, the value is cos 18.92, that is, this theta value is 18.92. Okay, are you getting? And then you have another force that is in the same FAC, and then that's all. You don't have any other horizontal force. You can equate to 0. Okay. So with this, we don't know what is FAB, we don't know what is FAC, so we cannot calculate the value. So for that, what we have to do means, next one we are having the next condition, that is summation of forces along y is equal to 0. That is, we are assuming that upward is positive. Okay. So based on the parameters of this sketch, okay, so we are having two forces, that is 5.7 is acting towards down, 21 is acting up, quite opposite, and also you are having FAB. So these three components will come in the vertical direction. So I am going to write upward is positive. So first one I am writing 21 positive, and then minus 5.7, and then you have another one is plus FAB sine 18.92 is equal to 0. So based on this equation, you can easily calculate what is FAB. So if you are substituting, you will get an answer of FAB is equal to minus 47.2 kilonewton. Okay, please substitute this value. Once you got this, okay, then this value you can substitute in this particular equation. I am denoting here, for example, 1. Okay, put it in 1. Obviously, you will get the other value, that is FAC. The FAC value is, based on my calculation, it is 44.6 kilonewton. Okay, please check it out. So now you got two values, that is FAB and FAC. Okay, two members forces we have calculated. Next we are coming to the next joint. So now we have calculated FAB as minus 47.2, and then here another one, FAC we have calculated 44.6. Okay, that one. So now we are going to move to the next joint. So next one we are having, as I said, B and C. So I am going with joint B. Okay. So in the joint B, so you assume the values. Okay. What are the forces are acting at joint B? We are going to see. So this is the point B. This one. Okay. So you know that when the point B is there, you are having one vertical force, that is 10.5 kilonewton. Am I right? And then you are having, this is point B, okay, B. So you are having 10.5 kilonewton. After that you are having a member force FBD, okay, and then you are having another inclined force, am I right, like this, that is FBA, okay, and then you don't forget that you are having another force, that is from B there is a C, so 10.5 kilonewton and FBC will act on same direction. 10.5 and FBC will act on the same direction. So now if you are putting it in resolution of forces, okay, like this, and then if you are saying that this is FBD, and in the same line you will have FBA, and then here you will have 10.5, and then you will have FBC also. Okay. So once you have done this, you can go for a solution of forces, and then you can calculate the values. For example, the first one I am taking Fx is equal to 0. We know that we are assuming towards right is positive. Okay. So if you are assuming that, I want to calculate this theta 2. The theta value will be 18.92 because it's the same, right? With respect to horizontal only you are calculating. So here also you are going to calculate with the horizontal. So whatever angle is here, the same thing will be here. So it will be theta 2 will be 18.92. Okay, that is BD cos 18.92, that is positive, and then you are having FBA, okay, that is minus FBA cos, okay, I will increase the thickness, so FBA cos 18.92. So any other force will come? No. So it's equal to 0. So from this you can understand that is FBD will be equal to FBA. Okay? Because it's acting on a quite opposite side. Okay. Opposite direction also you can say. So next one, once you have calculated this, okay. Next one you can go with the other equation Fy, that is upward as we are assuming it as positive. Okay, this symbol. So sigma summation of Fy upward is positive we are assuming. So that is equal to 0. Okay. So once you are substituting this, so from this diagram, you can easily write that as 10.5 because it is acting towards down, negative, minus FBC. So minus, you can write minus FBA sine 18.92, and then you can write one more force, that is plus FBD sine 18.92 is equal to 0. So this entire equations, okay, will give you the values of FBC and FBD. Okay, so anyway, you know already you have calculated FBA, so you can simply substitute and then calculate the value of FBD. So what is the value of FBD from this? Because we said FBD is equal to FBA, so you will get the value of FBD. So FBD you will get minus 47.2 kilonewton, and then if you substitute FBD is equal to minus 47.2 kilonewton in the equation 2, you will get FBC as, based on my calculation it is minus 10.5 kilonewton. Please check it out. Okay. So now you got other two member forces that are I think FBD we got now, and then we got FBC. Okay. So only the left out members are CD and CE. So we are going to calculate next the joint C. Okay. That's right. Okay, just to go through and check your answers. Okay, I am getting FBC as minus 10.5 kilonewton, and then FBD as minus 47.2 kilonewton. Okay, based on the previous calculations, we have calculated this force, that is FAB we have calculated, and then we have calculated FBD, and then we have calculated this force, that is FBC, and then we have calculated this force, that is FAC. So only the left out forces are 1 and 2. Okay, there is FCD and then FCE. So these two things we are going to calculate by considering joint, yes, you are right, C. Okay, so now when you are considering the joint C, I am going to draw the free body diagram with respect to point C. You can see here, this is the point C. So you are having force CE, and then you are having another force, vertical force FCB, and then you are having another force, that is FCD. So another force in the left, that is FCA. Okay, so I think we calculated FCB FCA we have calculated, so that we can substitute FCA value and FCB value to get the unknown values of FCD and FCE. Okay, anyway, first one we will solve now. Summation of Fx, that is towards right, we are assuming it as positive. Okay, that is equal to 0. So if you are taking that, so we have to calculate again the theta value for FCD. So when you are calculating the theta value for this particular one, you have to consider this triangle alone. Please take a note of it. So only this triangle, that is C, E and D, you have to assume. So now the vertical distance will be 2.4 and then your horizontal distance will be 3.2. Okay, so you can put tan theta is equal to 2.4 by 3.2, and then you will get this. I am taking as theta 3 for example. So the theta 3 I am getting as 36.87. okay, as per my calculation. Okay. So now we can substitute. Now that is first one I can take FCE because it is in the positive direction, and plus FCD cos 36.87, and then you have another force minus FCA, okay, that is in opposite sense, is equal to 0. And if you are substituting the value FCA, and then you will get a relation with respect to FCE and FCD. So we are having another condition, equilibrium condition, that is summation of Fy is equal to 0. So we are assuming upward as positive. So if you are taking that condition, the FCB is acting towards up, so it is positive, and plus FCD sine 36.87, okay, 36.87. So this equation you can assume it as 3 for solving, it will be easy. So here in vertical force FCB plus FCD sine 36.87. So no other vertical force also, so you can equate to 0. This particular one you can equate to 0. Okay. So once you are equating, you can easily get the value of FCD 17.5 kilonewton. So as per my calculation, okay, FCD. Okay. FCB as minus 10.5. Okay, please take a note. Please substitute the FCB value as minus 10.5. Are you getting? And you will get the FCD value as 17.5. Once you are substituting this 17.5 here with FCA value, so you know the FCA value is already we have calculated. FCA is this particular value of FCA is, as per our calculation, it is 44.6 FCA. So once you are substituting this 17.5 in equation 3, you will get the value of FCE. You will get the value of FCE. Based on my calculation, I got 30.6 kilonewton. Okay. Fine. So these are the calculations we got. Okay. So next one, you are having one more joint, that is joint E. All the member forces, that is we have calculated AB, we have calculated AC, we have calculated BC, we have calculated BD, we have calculated CD, and we have calculated CE. Okay. So we have to calculate one more member also, that is ED. Okay. This member also we have to calculate. Anyway, CE will be equal to EG. So now we are taking the point. So now we are taking the point E, that is nothing but joint E. So once you are taking this joint E, so you know that one vertical member force is there, that is F ED, right? And then you know you are having F EG, and then you are having F EC. Reconnect. So these two are equal. Already we got the value. So that is F is equal to FEG. So the FEG value is 30.6 kilonewton. Okay, as per our formula, that is positive. Okay, we can relate. So this is the condition, equilibrium condition. So coming to the vertical, you are having only one vertical force, that is FED. There is no vertical force acting, so this is value of the force in this member is 0. So this particular member is called as zero force member. Okay, that's all about this problem. So if you want me to summarize, I will write the answers here. So based on our calculation, we can summarize our answer. So FAB, we got, you know that, this particular member A to B. Okay, A to B. I am drawing separately so that you will understand. A to B. And you are having AC. Okay, having A C member, and then you are having B and C member, and then you are having C and D member, and then you are having B and D member. Okay, this is another member, and then so once you know this, then the same symmetry only about, you know that it is HF and then DF and then GD and then EG, everything. Okay, that's the thing. So, okay, if you want, I can draw one more, that is C and E. Okay, these members. So all these members I have drawn, that is I have drawn AB, I have drawn AC, and then I have drawn BD, and then I have drawn BC, and then CD, and then CE. Okay, so now based on the member force, we are going to say what kind of force. We have found that the member AB, the member AB in compression, the value is 47.2 kilonewton. Okay. Similarly, we are coming to point AC. So AC we have found it is in tension. So AC we have found that is in tension. The value of AC is 44.6 kilonewton. Okay. And then BC we have found, that is BC is in compression, and then value is 10.5 kilonewton. Okay. And BD, okay, so the BD we have calculated, that is also in compression. This one and this one. The value is nothing but, we got 47 kilonewton. And then CD we have calculated, and then we have found that it is in tension. The value is 17.5. Okay. And then CE we have calculated, and then it is found that it is in tension. So 30.6 kilonewton. So similarly, you can calculate for all other members. Okay. So you know that the zero force member, that is DE. Okay. So DE, the force value of FDE, that is FED, is equal to 0. Okay. This is called zero force member. Fine. So please post your comments as an answer in this video. Okay. Thank you. Have a nice day.